today class number 11. Class number 11 for electrical machine 2. Okay, so today the second class for 3-phase induction motor. So today I will discuss the generation of 3-phase rotating field in 3-phase induction motor. So this concept already I have been discussed in the previous module. So today I will summarize it and again I will discuss, but this discussion is little bit broadly, okay, little bit with some extra theories. Okay, so let us consider, let us consider rotation, generation of, make some heading first, generation of 3-phase rotating magnetic field or rotating magnetic field by 3-phase stator input. Okay, so before start I would like to express that I am taking this A axis and this is B axis having same magnitude. Always remember it is having the same magnitude. Okay, the magnitude of them are same, that is C axis. Okay, so A axis, B axis, they are 120 degree from apart each other. Okay, so this angle actually made in electrical degree. Okay, made in electrical degree. That means what is the electrical degree? What is the difference between mechanical degree and electrical degree? Mechanical degree means suppose you are taking these two, these two pen and angle 60 degree. Okay, approximately this 60 degree or approximately this 120 degree. Okay, and electrically means once A is traveling, after 120 degree displacement it will start, B will start, and after 120 degree again displacement C will start. That is, they are lagging with respect of A by 120 degree as well as 120 degree respectively. Okay, so write some points. Salient poles are used in 3-phase induction motor. Second point, total number of pole (3n), where n equals to 2, 3, dot. ठीक है? Here I consider number of pole equals to 6. That is 2 poles per phase, north and south. Okay. Stator winding are connected in star fashion. Connected in star. That is Y connected. Okay, Y connected in star connection. And stator winding have 3-phase balanced input, which is very much important for generation of rotating magnetic field. So that's why I am written in another color. Okay, so these points you have to first consider, and then you have to draw a 3-phase balance system. And how to draw a 3-phase balance system, I am here to see you that a new technique to draw the 3-phase balance system. Okay, Okay, so make first triangle. Okay, make first triangle, and then join this triangle by C. So first, this is first phase. This is phase A. Okay, and second phase, this is phase B, which is very easy. And third phase, phase C. Okay, so this is phase A, this is phase B, and it is phase C. Okay, so very easy to way, right, to draw it. So this type of technique you have to make yourself. Okay, ready. And now I am taking 3 instants. So first instant, second instant, and third instant. Okay, so at first instant you can see that, so I think this type of concept already I have been given to you. So at this instant, this first instant, A phase is maximum, so I am writing A phase is maximum in its own axis, and B phase is negative half. On B phase is negative half, or negative a portion, a ratio in negative. So what is the B negative? So in this direction, so in this direction. And C will be also at this situation, so C will be at this situation. So if we add them, then what happen? The resultant one will be, if we add them, then resultant one will looks like here, right? Some extra value due to this summation of these two. Okay, so at this instant the resultant flux is in this direction, and at second instant, that is, so this instant, suppose make right, so this instant will be omega t, so it is here omega t axis. Okay, so omega t equals to first instant, omega t equals to it is 0 degree, it is 90 degree, it is 180 degree, yes, it is 360 degree, right? So it will be 120, another 90, and 120 another 90 will be 210, right? It will be 210 degree, and this will be 240 plus 9, this is 240. From 240 plus 90, that will be how much? 330. So I am taking instants at 90 degree, at 210 degree, and 330 degree. Okay, so now omega, first one is omega t equals to 90 degree, and second one omega t equals to taken as 210 degree. Okay, so at 210 degree, what will be the direction? At this situation you have to find, and B will be maximum, so B direction will be this one, so B direction will be maximum, and A and C are negative half. So A negative half and C negative half, right? So if we add them, then your direction will be slightly added to this direction. So your resultant direction will be, at this situation it will be, okay. So at this situation it is in this direction, at this situation it is in this direction. And now omega t equals to (330°). See, every duration is 120°. The duration in between these two are 120°, right? In these three. So at this situation, so C will be maximum. So C direction is, C will be maximum, and B and A are negative half. So A will be negative half. A is positive here, so negative will be here, and B is positive here, negative will be here. So if we add, then the resultant one will be slightly added, because the resultant one is overlapping over here. So at this situation, at omega t 90°, omega t equals to 90°, it is looks like here. Omega t equals to 120°, omega t equals to 210°, it will be look like here. And 120 omega t equals to 330°, it will be looks like here. So every at 120° duration, it will rotate 120° in electrical degree, right? So this way it will rotate actually. So from here to here, so from here to here and here to here, it is rotating. So resultant flux is rotating in air space. Okay. So right here, so this caption, this is the resultant flux direction. This is resultant flux direction or plotting, resultant flux plotting. Okay, so right here we take 3 points. Here we take 3 points only, right? Here we take 3 points only, which show that the field is rotating, So if we take a number of points, in between these sections, then we can see that the stator three-phase field is rotating smoothly and forms and traces a circle, and traces a circle. Okay. So if we find any points in between these two, so then you can easily check that it is rotating in this direction, that is anti-clockwise direction. Okay, flux is rotating, so this looks like flux is rotating. Okay, so here right, rotating speed, some conclusion, rotating speed of flux called synchronous speed of the machine. Okay, taken as ns in rpm and omega s in rad per second and small ns in rps. Okay, so this is for geometrical interpretation. So now I will move into the mathematical interpretation. So what will be the mathematical interpretation of it? So mathematical interpretation, so do some heading mathematical proof. So phi 1 equals to what? Or phi of A, right? Flux induced by A phase equals to, what will be the flux? So phi m cos 0 plus j sine 0 degree. Why? Because I am taking in reference. So phi of A is in reference. Suppose we are taking flux. So we are plotting actually the flux over here. Okay. So flux per omega t. Okay. So phi of M sine 0 plus cos 0 plus j sine 0. Okay. And phi of B equals to what? Phi of B equals to flux induced by B phase. That will be phi M. So this is your phi M, right? So what is phi M? The magnitude of each pole is phi M. This value is phi M and this value is minus phi M. Okay. So phi M cos. So they are 120 degree apart. So cos 120 plus j sine 120 degree. And phi of C equals to flux induced by C phase. That will be equals to phi M cos 240 degree plus j sine 240 degree. Okay, so now add these two. So what is the resultant flux? So resultant flux phi of R equals to phi of A plus phi of B plus phi of C. So taking phi of M as a common. So cos 0 plus j sine 0. Cos 0 equals to 1. That will be remain. And so next one. So if we add actually, then you can see that say that it will be 3 by 2. You can say. So just do this calculation. Just put this cos 120 degree value, cos sine 120 value, cos 240 value, cos sine 240 value by your own calculator. Then you can able to see that these values will be coming here 3 by 2 okay. So it will come in 3 by 2. So that is what is the resultant magnitude. So I am taking the magnitude over here. Okay. So I am taking the magnitude only. So no need to write the phasor quantity. So phi m 3 by 2. That is 3 phi m by 2. So whatever the magnitude, it will be 3 by 2 phi m. That will be the resultant of it will be 3 by 2. That is whatever the phi m, it will be again added by half. So resultant will be 3 by 2 phi 3 by 2 phi m. Okay. So now if we find if we want to find the phasor quantity, then you have to add sine omega t over here, and here sine omega t minus 120 degree, and here sine into multiplied by sine omega t minus 240 degree. So then you can see that here it will come sine omega t minus plus j cos omega t. Okay. So it will be look like so an angle will be 90 degree minus omega t. Okay. So this is your resultant flux in phasor quantity. So actually phasor quantity you have no need to find. So you have to find only the magnitude. So you can neglect this sine part, sine omega t minus 120, sine omega t minus 240, and then you can calculate the reading, that is 3 by 2 into phi m. Okay. So let's you can verify it. So today's class up to this much. Next day I will start the detail and the main theory of 3-phase induction machine. Okay, or 3-phase induction motor. Okay, so today's class up to this much. Thank you.